The idea of this session is to discuss one of the no-code or codeless machine learning platforms called as Knime, Knime. I suppose this will be specifically useful for biomedical engineering students because most of them have taken bio or biology group in 12th standard, and they are not that comfortable with coding or programming. Having said that, uh, these days we have sufficient development in technology so that we'll be able to do coding without writing, all this programming lines and all that. We can do coding visually, and Knime is one such tool, visual tool, or a workflow-based tool, and we'll just get started with that. This session is more like a primer to that. Okay, one of you have used 3D slicer, right? So this Knime is almost like a multi-sim like tool or a 3D slicer like tool where you drag and drop different elements and perform computational operations. Okay, I had shared some code link to everyone and also the Knime link. I suppose all of you have installed Knime. Okay, you are welcome to try this along with me. Let me share my screen. I hope only my Knime window is visible, right? If you have Knime, let's do this parallelly. Okay, first thing is let's create, start from scratch. Let's say new workflow. Okay, it almost looks like your PowerPoint workflow of sorts. Okay, and give it some name, ECG Knime primer. Okay, now what we have is an empty workflow based reader. Okay, the first thing that we are going to do is to read an input file. In this side we have Knime Explorer, some node repositories, okay, some outline. This is essentially the view of the workflow where we'll have different nodes. The nodes, all of them we can get from here. Okay, and then some basic messages over here and some help and description towards the right. First thing is I have data in a CSV format. CSV is like almost like a Excel file, right? First thing to do is we have to read that file. Notice the moment you put a reader, you have an Excel reader, file reader, okay, complex format, ARF, CSV, line reader, and all that. What I have is a CSV file, so I'm going to double click a CSV reader. Here I got a node. Okay, some descriptions about that are all given over here. Any node. Okay, now nothing, no detail is set about it, so we have this explanation, mark with a red point. First thing is to configure it. To do that, you have to do a right click, configure. Okay, automatically it's going to ask you, okay, what file do you want to read? Is this window visible? The window is not visible, right? Whatever window open. Okay, let's just give me 1 second. Yeah, the moment you right click any node, you have the first option is to configure it. Okay, here essentially this is an object or a node, okay, used to read files, specifically of CSV format. I'm going to read the file that I had. We have I have 4 files over here, 4 CSV files here that I had shared initially. Okay, the train CSV files, train label CSV files, and then test CSV files and test label CSV files. Okay, so we will train this machine learning model using the train and train label data. First, let's quickly look at what this data is. Okay, so let me open this data. Okay, notice as soon as I select that file, now it is actually reading that file. Okay, what I have here is about 10,000 rows are being displayed, right? We have the row ID over here, row 0, row 1, 2, 3, and all that. This is the information in the first row. This is almost like a matrix where in this case the first row has 255 columns. It's essentially one single heartbeat. Row 1 is a heartbeat, row 2 is a heartbeat, and so on and so forth. Okay, like that we pretty much have like 10,000 plus rows in this place. So let's just click apply and do okay. Notice now the exclamation mark disappeared and what we have is a red or a yellow dot, right? Yellow dot says that, okay, this has not been executed. That is, the output is not available for, subsequent nodes. In order to get the output, you have to do right click, execute. Okay. It's running, it's 5, 10 percentage, okay, 20, 30 percentage and all that. The moment it runs, any data in the file, you should be able to read it, okay, as an output here. Let's quickly look at this. And yeah, notice the green signal says that, okay, things are fine. Now we have data red and it can be used for further processing. Okay. Typically, to look at the output of any node, you right click that node, and at the bottom of this, after cut, copy, paste, undo and all that, you have the outputs. Okay, this is essentially the information we already noticed during reading it. Notice there are about 22,632 rows here and 256 columns. Okay, each row is a heartbeat, so there are 22,632 heartbeats. Okay. Okay, this is one file. Now towards the end, we'll also like plot and see how one of this heartbeats look. Okay. Before we do that, the idea is now each beat is of a specific type. The type of heart is there in a slightly different file. So let's read that file over there. Okay. So again, I'm going to have a CSV reader, and in the CSV reader, let's configure it. ECG MITBH and train label. Okay. Notice here we have like again 10,000 plus rows. We have like 6 columns. Okay, 0, 1, 2, 3, 4, 5, 6. Okay, so let's also read this. You know which file to read it, and let's execute it. Okay, we have a green signal. Let's see what's the output. At this thing. Notice again we have like 22,632 rows, and we have 5 columns. Okay, this data is essentially the label of each of the beats. Okay, first column corresponds to a normal beat. Okay, if it is 1, okay, any row only one of the columns is non-zero. Notice the first row, it is row 0, it is 1. Okay, column 1. In row 1, it is column 3. In row 2, again it's 1, 1, 1, 1, and so on. Notice in row 53, you have like column 3 is non-zero. Okay, is 1. So this is known as one hot encoding. So the first column corresponds to normal beats. Then we have atrial fibrillation beats, that is arrhythmia beats. Then we have some premature ventricular beats and all that. So we have like almost like 6 classes. The fifth column corresponds to noise, okay, or the data is not good. What we want to do is, again, each of these rows corresponds to each of the rows in this training file. Okay, where I got this data, this is known as ECG MITBH data. Okay, we have another video on using Google Colab, right? In that video, we kind of discuss how to download this data, how to process this data and all that. So each ECG beat, we kind of know what the label is. First thing we want this in a format where we have at the end of each row, we know what the label is. Right now, this information is separate, this information is separate. Okay, we want to combine those two information. So I'm going to do a slightly non-trivial step. Idea is, let's look at this information. Let's quickly see. Okay, given this matrix, if I have to output, there is a 6th column. Okay, if column 0 is 1, it should say 0. If column 1 is 1, it should say 1. If it's like programming MATLAB, any simple programming, it's very straightforward, right? Can you do that in Excel or something like that? That is, here it should we need to have a new column that has the non-zero value. So here we should have 0. Here we should have 3, 0, 0, 0, 0. Then notice again on row 88, it should be a 3. Okay, because column 3 corresponding to that. We just need a 6th column that says the label of the row. Or we need a 6th column that says where it is non-zero. Label column that says this is normal beat. Okay, For this row, it is actually premature. This is 1. So we need the label corresponding to that. Let's say premature ventricular contraction. Somewhere else, let's say the 5th column is non-zero. We want the label corresponding to that. Let's say all we have to do is we need to have one more column which says the labels corresponding to this. Okay, the way to do that in Knime, okay, without coding, again we need to find a appropriate node corresponding to that. Okay, here we have something called a rule-based engine. Okay, I'm going to choose that row and let me configure that. Okay, if the value in the 0th row, okay, equals 1, you should give, let's say, normal. I'm following this format. The truth corresponds to the default outcome. This is a normal bit. Okay, let's say what we get. This is the only rule that we apply. Let's execute it. Notice we have a new column here. Whenever things is 1 here, it says normal. This, it doesn't know what to call it because we didn't give a rule here. This, it says normal, and so on. Okay, idea is, okay, if it is this column is 1, it should have a different label and so on. Technically, I should have had the labels as this. Okay, normal, 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 arrhythmia, okay, atrial fibrillation, premature ventricular contraction, all that. I didn't have it like that. Just that each case is given labels indirectly like this. Okay, so there is some little pre-processing, and let's quickly go reconfigure this. If the value in column 1 equals 1, we should get, okay, let's not get into the names of this. Let's just put column 1. Okay, and then we have column 2. If the value is 1, let's say 2. Okay, column 3, value is 1, we have 3. Okay, column 4, value is 1, we have column 4. Okay, column 5, value is 1, we have, let's call it, this I know is noise, so let's give it that name. Okay, the moment we do that, let's execute it again so that our new configuration works. And when we look at the classified values, notice now wherever this is 1, we have normal. Wherever the third column is 1, we have 3. So on and so forth, 3, 3, 3, 3, 3. So most of this is 3. Most of this, I suppose, is okay. No, notice now here there is 5th column is 1, so we have noise label and so on. Now what should happen is this column is known as this is what we are trying to predict, and of course it's also this is the label that we are trying to predict, and it's this also the name is appropriate. This column is named as prediction. Okay, the data that we are going to use to predict is over here, right? The ECG signal. Each row is a ECG signal. This row, notice, is one row is one ECG beat. Now we have to combine this and this. Typically we want to the data that we use to predict, that is referred to as X. The data we predict, that is referred to as Y, in a single file. Okay, so let's take the last column here and combine it with this thing. So any operation you want to do, it's very, very intuitive. Look for anything like splitter. We want to split column. Okay, so let's go for a node that does column splitting. Again, let's configure it. What we want is, we want only the prediction. We want to split the first 3 labels, the encoded labels from the labels that we just generated into 2 parts, so that we can send this part to the, if there is a combined node, we can do that. Okay, let's say if there is a combine, notice there is something called a column appender. Let's configure this. This, one of the inputs to the appender comes from our ECG bit by bit data, right? The other one shows up from, there are 2 output ports here. Okay, if you are in doubt, okay, is it the top partition or bottom partition? Look at the partition. Notice the bottom partition doesn't have anything. Okay, we have to execute it. Once you execute it, notice if you look at the bottom partition, we only have the predict labels, right? So let's send this as a second input. Let's also make sure the configurations are fine. Identical row queues, say table lengths. Okay, and let's execute this. What you have at the end of that is, notice row 0, we have 256 columns. Okay, so each of these columns are the x values, and this y is the value that we are trying to predict. Okay, once you have data in this format, the data that you're using to predict the ECG signals, 255 points in a row, and the label that you have to predict, you can send it to any machine learning classifier. In this case, we are going to use something called a random forest. You don't have to do any training or any of that here. Okay, so as soon as you type random, you have random forest as a classification algorithm. Let's get that node. Okay, it only takes one input. Of course, it's a model that we are trying to predict and all that. Let's also configure this. Notice the data it's going to use to predict is all the columns from 0 to 255. Automatically, it kind of knows what the prediction is. The target column, it says, it's a prediction column. Okay, so with X, you are predicting Y. Okay, the X is the ECG signals that is being included in the data. Okay, none of the columns is excluded. The column that you are predicting is goes by the name prediction. So by default, things are already set well, and just execute it. Notice, so all the nodes here is roughly shown as the outline here. Okay, so you can easily browse through this using the outline window. Let's give it a few seconds before it completes. Okay, now this thing ran, and let's quickly say what it has. It has a model that is give me any new ECG bit. It has a model to actually classify that bit. Okay, one of the outputs, one of the ports. Then it has like current attributes on, okay, what is important and all that. For each column, it kind of has some things, and the current model, how it's predicting the class labels is given by this column. Okay, but that's not of importance. We should be able to use this model to predict on data that we haven't used in training. Okay, whatever data we used here is known as training data. We have to use some new data, okay, other than that we used for training. So let's quickly copy this set of cells over here. We need to do the same thing for what we call as test data. Okay, so I just copied them as such. Let me paste them here. Let's quickly change the configuration in the reader for the train data and all that. Notice we have the training data here. Instead, let's change that to the test data. Okay, so this is test. Okay, and this also should be test labels. Okay, so if you browse, let's use the test labels. Again, notice we have 5 columns, but we want the label at the end of it. So it goes through the same thing that we obtained here. Let's configure this so things are fine. Let's just execute this. If we execute this, of course, all the preceding nodes are going to get executed. And notice what we have at the end of the day. If you look at the data there, it's 4,492 rows, 4,492 ECG beats, each with again a different label. Some of them are normal, some of them is noise, okay, some of them is label 3 and so on. Now let's take this model and see how it predicts with the new data. Okay, the way to do that is again another node. So random forest learner is there. There is something called random forest predictor. Okay, where the prediction data goes in. This is a new heartbeat goes in as an input here, and model that we already trained goes in over here. Okay, let's execute this. Now, if you look at the prediction output, so for each of this is a label that was already there, and this is a new label that got predicted right now using the model we trained. Okay, this column is a new column, that is the ML part. So given any new heartbeat, you can pretty much, without this information, without this column, without the actual labels, you'll be able to predict what an label is. Notice some places it's actually making a mistake. Okay, many other places it's correct. Right, the actual true label is 3. It thought it's a normal label. Here it's normal. It thought it's predicting it's a normal label. Okay, let's also give this quick, let's quantify this. Okay, how well is this model that we trained performing? For that, there is something called a scorer. Let's take a scorer node and take this output into the scorer, and let's configure this. What it says is, okay, now we have the true, we have truth, and we have prediction. How good do they match? Okay, so first column is truth, second column I set it as the label. Okay, and let's make it okay, and let's execute and see what the results are. Yeah, notice here we have the actual labels. Most of the normal labels, okay, it kind of predicted as normal. Some of the normal labels it mislabeled as noise, some of them mislabeled as 3, some of them mislabeled as 1, some of them mislabeled as 6. Okay, similarly the actual noise beats, most of the noise beats, okay, 387, it kind of labeled correctly. Some of them was labeled normal and so on. Okay, this is known as a confusion matrix. The actual quantifications are given over here. Out of the roughly 4,400 samples, okay, 4,500 samples, test samples, 3,600 beats got correctly classified. About 800, 900 beats got wrongly classified. So the accuracy here is roughly 80.3. 80% of the time it's actually labeling the beat correctly, and 20% of the time it's failing. One thing is, of course, you want to make this, get this close to 100 as much as possible. But right now, by using a better model with better configuration, better parameters, typically we can get better score. Okay, but you notice all of this is typically done in a using code, typically in Python or MATLAB. All of that we could essentially do like in a workflow based approach. Just each node has an input and output. Once we set the configuration correct, it does what it's supposed to do. Quickly. So now, any questions with what we have done here? What is this machine learning that we have done, and how this works here? We'll spend about another 10 minutes or so here. In this case, each row is a ECG beat. Each row could be an image instead. Each row could be a signal from cell phone data. The label that we have here is, okay, now someone fell down, someone did not fall down, someone is walking, someone is cycling. Right? Could be acceleration data from cell phone. Okay, or you're trying to come up with a brain computer interface. This is just muscular EMG data, and then for each action, type of action, you have the EMG signal. And then action, you trying to lift the hand, trying to lower the hand, trying to abduction, adduction, and all that. You can have labels. Okay, so in this case we have like normal ECG beat, this and so on. Okay, so this is the CSV file you typically start with. Okay, and once you have that, this is all the detail that is involved. You send it to a model, you get the model, you check how the model results do, and typically you want to do that with some new data. Okay, this is known as test data. Okay, I did few steps here, because we did not have data in the right format, and this also, in most scenarios, This is the case. Okay, you'll have to do some kind of pre-processing or data wrangling before you have it in, the file format that you want it in. And notice we have tons and tons of nodes over here. Input output nodes, reading, writing data, and all that. Okay, if you want to do data manipulation, row column operations, table operations, all of that you have. Okay, you want to filter by specific things, you have nodes for that. Most of the things, whatever you could do in Excel or MATLAB, most of that you should be able to do that. Then if we want to view the output, let's also show that. Okay, you can also visualize information here. I said this is ECG data, right? Notice what we had is like ECG data. Let me go here where we have only the ECG signal without the label. Okay, let's plot one of them. So first is we have to, uh, we can only plot columns. So we have to take rows and transpose them. Okay, so first is splitter. Is a row splitter. Yeah, there is a row splitter. Let's identify one of the rows. Let's get rows by number. Let's have just the 10th row. Okay, I'm just going to have only one row. And notice it has two ports. The filtered row. Okay, data is not over there. Let's execute it. Okay. Yeah, we just have the 10th row, which has the ID of row 9. Right. Let's quickly transpose this because only columns can be plotted. So we have a transpose. I'm going to transpose the filtered row that is at the top port. Again, quickly configure that. By default, things, whatever things are there, it should be fine. Now, once you have filtered, let's look at the transpose table. Now, this is this column. Okay, we have the row ID here. This column is the ECG signal. Okay, if you don't trust me, let's quickly plot that. If you search for plot, we have a couple of options, box plot and all that. I think we can use line plot for this. So again, take this output and feed it to line plot. Quickly configure that. I think most of the things should be set fine. Your x-axis is row ID and your y-axis, what you're trying to plot is row 9. Okay, so things are again by default set fine. Let's execute and see what we have. Notice, so we have this ECG signal. This is, there are 255 points here or 256 points here. Okay, 0. So that's the data that we had. So for each of these 256 points plotted here, we kind of assigned a label. Let me close this. Okay, so essentially what we did is we plotted the row 9 over here. This node, notice this is just a ECG signal over here. And of course, we have the label data, which we kind of appended here. So the 9th row happens to be a normal read, so looks fine. So this is essentially a tool. You don't have to really, code. The only thing I did here is some rule engine where, I had to combine a couple of columns. Those things, whatever typically you could do in Excel, MATLAB, you could do here. When to use which node? First thing is, see, first of all, I was looking for a tool, that will be useful for specifically for BM engineers, no code tool. And we kind of found it, tested it along with one of your seniors, okay, biomedical engineer named Prabha. And we figured the tool, we thought, there is no awareness among biomedical engineers that such tools are there that, where they don't have to do coding, but they can do machine learning, right? And once we got the tool and from there on, whatever we wanted to do, okay, first thing, our first guess is a classifier. Let's do, search for it. The moment you put classifier, it gives you lots of options. Of course, if you recognize what is gradient boosted learner, random forest, okay, k nearest neighbor, so on and so forth, okay, you can use that. In this case, random forest is a classifier. Uh, Logistic regression, if you're searching for that, logistic regression, again, notice there is a logistic regression learner. Okay, okay, sir, let's not use random forest. How do we use a different thing? Okay, let's get a logistic regression or something like that. Then let's look at the operations that we wanted to do here. I wanted to plot, so I look for the plot options. If we search in the node repository, it's an okay, box plot, conditional plot, ECG. How do we plot? It's either a line plot or this parallel coordinates plot. Only the line plot. Okay, when I tried using it, there was some trouble. Okay, I couldn't really plot it because I did not know, if I try to let's break this. Okay, let's take this CSV reader and let's try to give it. Okay, let's try to plot it. It will give you, plot vague results. Let's try to configure that. Notice your x-axis is row ID. There is no way you can only, uh, your x-axis is going to be one of the columns. At best, it's row ID. Okay, here itself, I kind of knew I cannot plot it. Okay, let's keep it at row ID, and then what are we going to plot? Let's keep it as such. Let's try to run it. Okay, we should get some observed result. Execute and open views. Let's give it a few seconds. Notice, yeah, error. The line plot view does not support more than 200 columns for y-axis, right? I got an observed result here. At this moment, this is where I go to Google. Knime line plot. Then I recognize, oh, no, it cannot plot actually any row. Okay. It can only plot columns. So then, okay, I have to separate the row that we want to plot, and then we have to, make it a column, and then do this. So first is separation is splitting. Look for splitting. Okay, we have cell splitter, column splitter, this. So most of the names are like self-explanatory. Okay, this is how we kind of found which node to use. Okay, I use a row splitter. Configure a row splitter. In most of the cases, the defaults are set very well. Okay, this has some kind of intelligence setting up default values. Here I specifically know, okay, I want to use specific rows. Okay, let's try to plot more than 10 rows. Okay, let's do okay. Let's do a transpose. Okay, only columns can be plotted, so we transpose that. Again, the defaults mostly work. Okay, let's give that to a line plot, and let's make sure things are fine. Your x-axis is row ID, and it can at max plot 2500 rows. Okay, that's fine. Let's plot and see that. And notice, no, we have, instead of one plot, we have plotted multiple ECGs. Okay, so the way to find the node is, first is go to the node repository, type in the word that you are trying to do, keyword that you're trying to do. Is it plot? Is it split? Is it learn? Okay, is it predict? Right? Notice here, okay, is it a naive Bayes, neural network, a decision tree, logistic regression is likely to be here. Okay, ensemble learning. So are you trying to learn, or are you trying to predict, or are you trying to plot? Type that, you should get it. Are you trying to split? Are you trying to read, or are you trying to write? Okay, if it's a reader, type reader. Okay, you can read Excel files, a couple of other file formats. Then you want to write things. Again, just type and write. Notice it's CSV writer, ARF writer, a couple of things, right? Excel writer, and so on. So the way to find the nodes is just first check the node repository. You have, whatever you choose, you have its documentation right over here, description right over here. What is the input? What is the output? Okay, what is the input port? What is the output port? Okay, configuration is kind of mostly set by default. You don't have to muck around with the configuration a lot. It kind of automatically knows what it's trying to predict. The prediction is, for example, in the predictor, it automatically predicted, uh, which column is going to predict. Okay, prediction column is predicted and kind of automatically detected that, right? The worst case, you have to go to Google and try that. Okay, Knime has an active community, nice documentation page, so you should be able to find results. And the only node that we have to kind of struggle for is this rule engine. Okay, now I have data this way. Let's look at it. Okay, okay, this is label one. It's kind of encoded this way. Okay, this class is encoded here. We kind of wanted one class so that we can send it to We needed info in one column so that we can send it here. How do we do that? We are Googling. Within like 5 minutes of Googling, we found this thing called rule engine where you can create a new column based on some of the rules that you put in. All it says is uh, row value is many things are possible: less than, less than or equal to, greater than, and in like matches. You can do text processing here and all that. Then what is the output there, right? By Googling 5 minutes, we kind of, okay, we have to use a rule engine to get a new column. And then, of course, we separate that column and split it into, mix it with this table. So just a repository and Googling could kind of solve most of our issues. You could do more complicated things here. Okay. But, in this primer, I wanted to primarily get an awareness and, wanted to help you get started with this so that you come across a project in a course. You quickly know it's dragging and dropping a couple of nodes and, doing that. There are lots of tutorials for Knime online. You can do image classification tutorials are there. Even text processing tutorials are there. You can go take a look at it. Even data mining, some complicated analysis should also be possible. Okay. Uh, but if you're interested, I think you'll be able to follow along. So a few things that we did not do very well today is no one usually gives this data, the ECG data, directly as input X to access to the machine learning. We typically extract features from here. We typically extract, let's say, no one gives this as a data. We typically extract, okay, what are the what is the QRS duration, what is QT duration, things like that. We kind of extract features and give it to it. There are, you can extract features in multiple levels. Okay. We did not do that step today. And also we do a lot of parameter tuning. We also did not do that step today. That is, accuracy 80% is typically not satisfactory in most applications. Okay, we need a slightly better accuracy. Also, the objective was not that. We did not do that today. Perhaps some other day we can sit together and we can test out different classifiers and quickly we see how this works. 1 hour is to like testing the water. If you like it, if you think you could do it, now the ball is in your code. You should proceed further with it. Okay. Of course, if you want to do more advanced things, you get stuck at somewhere. You could let me know. I'll see if I can, provide any inputs or clarifications. Let's stop here. Then, I'll see you again